Okay, so now begins some of the both easiest and hardest problems in the unit. They might not be as tough as some of the mixture problems, but they're really hard to conceptualize. I'm going to call them work problems because they have to do with the amount of work that you can do, either mowing a lawn, painting a house, filling a tub, draining a pipe. Basically, whenever there's work that needs to be done by more than one person, we use a work problem. So, here's the simplest work problem you'll ever see. Alice can mow the lawn in 3 hours, Bob can mow the lawn in 5 hours. How long does it take them working together? So, I think we should start out by saying we can't just subtract it. It's not 2 hours. We can't just add them. It's not 8 hours. That wouldn't make very much sense at all. Why would it take more time for both of them working together than it took each of them working alone? So, that's actually a good test. Whatever answer we get, it should be less than 3 and certainly less than 5. So we want a number that's less than 3. It's not the average. It's actually going to come out to be something that we've done before in workshop called the harmonic mean. It turns out to be a good way to check your answer, but it isn't always reliable in generating the answer. So let's get started. After a couple years working on these problems, I've found that it's easiest to kind of think in a nebulous way about this. If we consider the amount of work done by Alice, and we add that, sorry, I should say in 1 hour, and we add that to the amount of work done by Bob in 1 hour, that should equal the amount of work that both of them do in 1 hour, right? Instead of saying both, I'm going to say A plus B. Now, you don't necessarily have to write this equation for every problem that you do on work problems. But I think it really helps to lay the groundwork. Now, you might be saying, Mr. Brescher, you haven't defined a variable. Good point. I think that defining a variable before I get to this stage, it's not really wrong. I just wanted to make sure that everybody saw how we're going to do these. So, now let's get to defining a variable. Answer the question, how long does it take them working together? So, time to finish working together. Okay, so if it takes Alice 3 hours to finish an entire job, how much does she do in 1 hour? Well, 1/3. Should I write this as a proper fraction? Okay, plus the amount of work done by Bob in 1 hour. So again, if he takes 5 hours to finish a whole job, he finishes 1/5 of a job. Now, if I add 1/3 and 1/5, that's not going to get me the answer. That's going to get me the fraction of the job that's done by both of them working together. So hypothetically, prototyping again, let's say that it takes 2 hours to finish when both of them are working together. How much have they finished in that 1 hour? Well, 1/2 of the job. If it takes them X hours to finish working together, then they finish 1/x in that time. So that's what I'm going to set it equal to. And all of a sudden this looks like the harmonic mean problem, the resistor problem, several problems that we've done before. Now, the problems that we did in chapter 1 having to do with rational expressions, you found the LCD. So here, what's the LCD of 3, 5, and x? Well, since 3 and 5 are co-prime, then it's got to be 35, or sorry, not 35, 15. So 15x is my LCD. Now I multiply everything by 15x. 15x over 3 plus 15x over 5 plus 15 equals, where are my letters? Equals 15x over x. Cancellation time, 15 and 3 cancels to 5, 15 and 5 cancels to 3, x and x cancel to 15. So I have 5x plus 3x equals 15. So 8x equals 15, x equals 15 eighths, or 1 and 7/8 hours. So our guess of 2 hours was actually not far off, but 1 and 7/8 hours. That matches the test that we set out in the beginning, that it has to be less than 3 hours. In fact, that's a pretty reasonable answer. Now the harmonic mean, where does that figure into this? Remember that the harmonic mean of two numbers is their product divided by their sum. So the harmonic mean of 3 and 5 is the product, 15, there's the 15, over their sum, 8. 3 plus 5 is 8. While I would encourage you to learn and use the harmonic mean, I will say that it isn't always going to give you the answer right away. It might be a way to check an equation at the end, but I wouldn't say that it's a reliable way to solve these problems. So with that in mind, have a try at number 8 and then play the video. Thanks.